Hey everybody, this is Larry. This is day 11th of the Leetcode day. Try and hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Uh the couple of you following me for my stock market drama. Uh I gave up on my trade and I was just kind of taking time to I lost, not gonna lie, I lost a lot of money. Um it's both life changing, at least sad, but also I survived, right? And then of course, like literally maybe like 2 3 hours later, uh, the news happened and everything went up. So I literally was so close from hitting that, but I missed instead, right? So yeah, let's just say it's been not great. Um, I'm actually in my bed right now because I just kind of been going, not gonna lie, I've been going through a lot of this stuff in my head, so I'm just kind of, uh, yeah, it's not great, suffice to say, um, and kind of just try to figure out how to learn from it, especially since I already paid the tuition, right? Um, eh, but that's kind of the update. I did do a little bit of running today, but I don't know. Not gonna lie, it's hard to think about anything, but but let's see if I can do this hard Leetcode problem. We have 2999. Count the number of powerful integers. You are given three integers: start, finish, and limit, and you're also given a zero index string representing a positive integer. A positive integer x is called powerful if it ends with s. In other words, s is a suffix of x, and each digit in x is at most limit. Return the total number of powerful integers in the range start to finish. All right. A string x is a suffix of a string y. Okay, yeah, okay. Guess I know what a suffix is. Yeah. Excuse me. Sorry, friends. Yeah. Um. Yeah. I'm a disaster. I'm in shambles. I literally basically caught the entire way down on the elevator of the stock market, and then didn't take it back up. That's basically what happened. If you're curious, and it's kind of literally the I don't know, like, and the weird, because everything for me is mathematical, so in a way I was proven right, but I just couldn't hold on to it because um honestly, I sized it a little bit too big for me to hold on forever. But I could have probably done less than all I did, but I was just ready to. I also thought that I had an extra couple of days to just regroup. Be like, okay, let's collect yourself, figure out what's the situation, and then see what you want to do. And then of course I missed everything because I was resetting. Uh, as they say, something when other people are fearful. All right, let's take a look at this problem. My fault. Sorry, it's just been a very crazy day, as you can imagine. So, hope you forgive me. Um, okay, let's see. Okay, so your zero index positive integer, a positive integer x is called powerful with ends of x s. X is powerful with ends of s. Okay, return each digit. Oh, s is an input. Okay. Okay, so then here, wait, what are the other oh, from this limit, right? All these integers have each digit greater than equal 4 and 1 2 4 as a suffix. Okay. Oh wait, what's limit? Where each digit in x. Oh, okay, so it's like that part is not that interesting. That's just like an if statement or something, or different for loop, because 5 is greater than 4. Okay. Huh. I don't know that there's anything that tricky about this. conceptually, but it is really annoying, right? Yeah, I think the first thing that I would do, and I don't know if I did that the last time I did it, is that because I don't always remember to do this, but I try to, which is that given that you want to, if you're trying to get a range of things from start to finish, you can always do a prefix sum of it, right? And what I mean by that is just that you have, you have the sum of 0 to, like, you can think of it as your a function that you want to get for a function of 0 plus f of 1 plus f of 2 plus dot 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 plus f of let's just say start minus 1, right? And then here you have the same thing, say, right? Go copy and paste because I'm on my bed. Plus dot 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 plus f of n, right? So then the idea here is that, okay, if you do a prefix sum e thing, then it is just if you want to get this range, then it's just this range minus this range, which is sometimes easier to calculate than inclusive range, right? So what I would do is maybe, and you wouldn't quite necessarily do it that way, or you would not necessarily do each number by itself, but it just allows, because it reduces the case analysis a lot. And in general, probably usually makes it a little bit easier, but I could be wrong. Right? Okay. Can't believe on the one day that I'm like not feeling super well, I have this ridiculous Leetcode problem that is probably I'm gonna be way wrong. So I'm just trying to find my charging cable, because I was like, okay, well, this is not gonna be a short easy problem, so I maybe need to plug in the charger. There you go. Because in here for a little bit longer. But yeah, so I would maybe write something like f of start minus 1, right? And f of n, right? Minus, assuming that in this case, not the same f here, f just contains everything from, well, in this case, it's this one and the other one, right? So yeah. Okay. Right. And then the question is, how do you implement this, right? Well, I mean, the first thing is that, of course, start and end could be really big, so you're not doing a for loop, right? Let's see, suffix, right? How do I want to think about this? Let me think about it for a second. Okay. No leadings. There was a little bit, actually. Maybe it just makes it confusing, right? But okay. I mean, the naive thing would be that, okay, right? So let's say you have 15. Well, look, it's not gonna happen, right? Oh, you have one number, sorry, right? So I'm trying to. Okay, is it one digit at a time thing, right? I mean, okay. So the first thing that we can do, I don't know if this is quite the right way, because a lot of these is honestly just case analysis. For this particular problem, it feels like, so it's just about a lot of different cases, possibly. If you have a very good way of thinking about it, it's possible that you can implement it in a way such that yeah. Is it just digit DP? Maybe it's not just case analysis. I mean, I think you can do no, it's not digit DP, right? Can it be digit DP? I feel like it's simpler than that, though, right? I don't know. I don't think we need digit DP, but maybe I'm wrong on this one. But here, basically, you just go, okay, well, and S is okay, fewer than whatever digits, just to make sure. Yeah, it's just counting the number of prefixes, right? So I don't know. Anyway, with the case, what I meant by case analysis is that then you can just kind of try it. Yeah, just break it down, right? And the first way that I would break it down is by looking at one digit at a time, right? So here, right? So here, let's just say ref x, right? You know, then now we know that we have this many digits, right? Let's just say d for digits. Then you can just do, okay, well, how many one digit number are there? How many two-digit number? Because basically if you have 15 and you can't remember from 0 to 15, or in this case 14, but you know, just 2 digits, then now you go, okay, how many one-digit number has s in it, right? And that's an easy way to, you know, as long as you don't do the precise number, right? That maybe we'll save for a second, but here we can just do a count, right? And the count is just should be the number of 3 digits that you have, which is power of, so if limit is 1, then you have 2 digits and so forth. So you have yeah, so length of s is this, right? So that means that for I, if I, we want to start 1 is less than yeah, if I is less than L, right? Then you know, then it has just strictly fewer digits. It just has to be that I minus wait, is it the other way? No, this is right. Wait, wait, no, this, it is the other way. Whoops, sorry. Because I has enough. Because if I, no, I'm confused. Sorry. If I has fewer digits, then how it ends, right? No, not L. What am I doing? No, sorry. This is I is less than. Sorry, friends, I'm clearly having a day. But I is less than D, and it should be, so we don't even need this if statement, which is why I got confused, I think. But yeah, then that means that I is, if I is greater, because if I is smaller than L, then the answer is just 0, right? So here, if it has exactly I, meaning that the current number of digits is exactly S, then there's only one case. I guess that gets priced in. Okay, so if I is greater than or less than L, or greater than or equal to, man, like I said, I'm so sorry for this video, but yeah, which means that you can actually just reduce this to here. In this case, maybe you have a total, right? And it's just total. We add it by the number of 3 digits, right? So if it's at least L, then the number of 3 digits is just L minus I, or I minus L, sorry. And each of those digits can be one of the limits, right? With limit at 6, then you have 7 numbers and so forth, right? So you have limit plus 1, or it's not times, sorry. Man, why am I so bad today? It's the power of, right? Because basically, if you have 5 3 digits, then each of them are 5. Oh, sorry, 5 3 digits, then each of them are 0, 1, 2, 3, 4. And then you have 5 of them, it's going to be 4 to the 5th because it's just the degree of freedom, right? Yeah. Okay. So then now we have to do exactly D, which is the input of X, right? I guess there are. So if they're the same, I don't know if this is necessary. I'm just trying to think, right? If D is less than L, then it's just 0 because that means that we don't have enough digit. I cannot apparently hit that, right? But it just means that you don't have enough digits, so it'll never be true because it's just like the number is smaller than the suffix, right? If they're exactly the same, then if they are exactly the same, then you have to just check whether if X is greater than or equal to int of s, then total increment by 1. And is that it? I'm trying to think. Because that means that, you know, the numbers, it has the same number of digits. So then now you want to add one more thing to it. Otherwise, if it's the same number of digits, okay, okay, well, I think, well, I mean, it's fine, but no, if D is greater than L, that's what this is for, right? So I think we're done, maybe. Which actually was, okay, and, a finish. Okay, well, I'll put 1 for 5. Why is that? Start to finish, 6,000. Okay. I mean, 1 is definitely not right. This one, 0 is also not right. 0, yay. No. Start is equal to 1. This should return 0. But 6,000, oh, no, whoops. No, still 0 for 1. 6,000 should at least give me the 4. Right? Oh. I don't do D inclusive because I wanted to do this check. But that means that if they are different length, I forgot that I didn't count the D length. So else if D is greater than L, because if D is smaller than L, then we just ignore it. If D is greater than L, then we have to do basically this math, right? Wait, is that true? No. If D is greater than L, it means that we have at least one number. You have, I mean, but it also means something else, right? Basically, what does it mean, right? And I think this is not that bad, but you just have to write out an example. But it's also like kind of hard, maybe. Let me double check. Because basically the idea is that, okay, let's say you have well, right, and then now your prefix is 2, 3, 4. Then what does that mean, right? Well, D is the yeah, it's not that this could be any. So yeah, we have to do the math here then, right? Because it goes up to this thing. So yeah, so it's not just quite that. How do I do it? Okay, so that means that we have to check the suffix then, right? Of this number, because if this is 200, then basically we think about this as just like almost like borrow this 1, I suppose. Is otherwise, if it's bigger, then you don't have to borrow the 1 because it just like rolls over. I think that's basically the idea, right? And of course, this is even true for no, yeah. I was trying to count. Try to think about a case where it only has 4 digits, but it could be anything of the 4 digits. So it's just this formula would be right, because the last 3 digits are fixed, right? And then the last digit could be anything you want. But here, what does this mean, right? Do I still have to care about the suffix? Yeah, I mean here, because here then now in concept you have 2 degree of freedom up to this prefix, right? Meaning that you know, it could be just 1 0, 1 1, 1 2, 1 3, 1 4, 1 5, ... right? And that's fine. Maybe 1 2, right? But if this is smaller than that, then 1 5 is not right. So you're essentially borrowing a 1, if you will, like in subtraction. So okay, so that means that basically we want to look at the the last digits of XS, right? So okay, yeah, this is too big. That's why I was like, why am I struggling so much on this? But yeah, so okay, so if D is greater than L, then we want the prefix is equal, or the, okay, so the prefix Okay, so the length of the okay, so prefix is just equal to xs all the way minus so length of xs, or which is already d, minus l, I want to say. I may be off by one here, to be honest, but yeah, because if this is 3, this is 5, then it goes from 0 to 2. I think this is right, but then now you also need the suffix, which is of x, which is just I guess it's just this, but I thought maybe that it would be a slicker way, but yeah, and then now it is the same as here, right? Right? I guess maybe we don't need to special case it now that I understand it a little bit better, right? Because then now we can just do this, and then otherwise, and in this case prefix should be 0, nothing, so that maybe is a little bit bad, but yeah, I mean, it should be nothing, which maps to 0, but oh, actually maybe that's no. Yeah. No. Okay, fine. I don't know. So maybe I did need the if statement anyway, because it comes out, because if prefix is equal to then total. So maybe I did need it anyway. Else then you have int of prefix, otherwise it throws you an error as y. So this is the number of things. Oh no, this is wrong, sorry, because you have to borrow the 1. I just kind of, okay. Right, so if it's greater than that, then let's say p is equal to prefix. So this gives an error, right? So so it has to be this, right? I guess it could just be like if p is equal to prefix, then p is equal to 0. Else you have this thing, and then now if it's greater than whatever, then it's fine. Otherwise, so you have p subtracted by 1 to kind of carry the 1 with you, or steal the 1 or whatever, and then now it is just, it's not this anymore, it is just the number of prefix. This is actually not right, but in theory it's just p times no, just p, right? Because it's just like for example here, if you have this, then it's just 152, right? Or 151 in this case, because you put or sorry, not one, this will be 15 or 14 because you're borrowing 1, right? But keeping in mind that this is not in base 10 because of limit, so that's the only other thing, right? Which means that we have to change from here as well, but that's not so bad. It's just that I think we have to just change this instead, right? Maybe we could do it this way, so then we don't need this anymore either, because what we want to do is shift and add, right? So for x in prefix, we want to shift and add, assuming that it is a base limit plus 1, right? Counting 0. So base, we shift and then we add, right? So shift and add. I don't know what this is. I guess I just copy and paste it, but it should be int of suffix. I don't know why I didn't. Right, and then here we borrow 1. Otherwise, yeah, that's good. Let's see if I'm lying. Hopefully not. Oh, why do I just do this? This is no, because prefix is an int or a string, and then we have to convert to an int. Let's give a spin. And still no bueno. I put 7 as a number, which seems high, right? We have 1, 2, 4. So you remove this. That should only be okay. Well, let me just point it out, right? Like at this point, I think it's possible for me to have an off by 1, so I'm not like that confident. So we can just print it out. Yeah, and 6 goes to 1. Actually, this is right. This is what we want. If int. Oh, I think I did it the other way, but I don't know that should have changed, because if it's small. No. Yeah. Except for it should be this. Oops. Because then now you're borrowing 1, right? Kind of. 6 and 5. Okay. 1, 2, 4. The 6 numbers that are from 1 to 4. That's right, right? Oh, because of 0, I cannot do leading 0 stuff. That's actually awkward. So the reason why this is 6 is that because I have leading 0. Right? Maybe? Actually, let's print it out. Because I think there may be other things that just gets cancelled out, which is actually not great. I think it's actually more... No, okay. So the print statement is fine, actually. Or like it's showing 6. Oh, no, I'm printing the wrong thing. What am I printing? Oh, no, this is right. Because we just had... I thought maybe this could count more than thingy, but okay. So then what am I doing wrong? Why is this returning 6? Let's look at this prefix suffix, right? So it should pause this P. This 6. Oh yeah, again I think this is the only special case though. Oh, maybe not. I think I am wrong on this one, actually. I mean, the idea is right, but I'm imprecise. What I mean by that is this idea... this is wrong anyway. What I mean is that, like, we have 124, and what I said is that, like, maybe 15124. And I think that I was like, oh, you can just take the 15 and then just do the count, right? But that is what I'm doing here for the other digits. Right? And that is not quite... Actually, is it right? I guess it's fine. It is a weird example. Also 6,000 is... There's no leading zeros. It's fine. But I think... Oh no, because S cannot have leading zero, so that should be fine. No, so 6 should be fine, right? Because it's 0. Oh no, because I'm double counting. Because then now... in here we add the first digit as 6, but then it means that, yeah, I'm double counting that one, because then if it's 0, then yeah, okay, fine. Remove 0, because if it's 0, then you already counted it as part of the other formula. That's why. Okay, well, I'm still wrong, so still a little sad. Just real quick. Okay, are we close? 3, 2. Okay. Why? Okay, let's print this real quick. Oh, this is also bad that I reused this X as the input. So maybe I need... Let's see. At least for printing purposes. But it's still bad either way. It's just worse. Okay. I mean, -1 is good in the sense that you know that's wrong. Yeah, I mean, I guess that's it. We just have to cap it. I didn't really pay attention, but yeah, because when we do 14, that's not right. There should be... It's not 0 though. That's what I mean, right? So... Even though that would fix the answer, I don't think that's right. It's this one, right? If 10, then you have 2, right? And also 215 should give you 3. So something's really off. Unless I don't have to remove 0, is that why? No, you have to remove 0 because... Okay, so P, what did I put? P is equal to 0. So, and then the prefix, there's no prefix, so it's just P is equal to 0. And then we subtract 1 when this is good. Why do I do that? Was that just from before? No, because this is from the idea of that you have to borrow a 0 from P. But So I guess it being so 14, but this should not return 0. This should actually return 1. So it's off by 2, right? That's what I'm taking. And it's not about removing 0. Also, we should only remove 0 if t is greater than so maybe we didn't need all these random cases. Yeah, so that should fix. I don't know. So yeah, this is still wrong, right? It's just that we got a little bit lucky with the offsetting things, which is why we do want to print this. Okay. Yeah. Why? I guess we can print out prefix suffix, right? Prefix suffix p, right? Did I not? Oh no, that's only in the other thing. I think that, but that's probably the important part. The other parts are easy, so I don't really worry about it. Okay, so prefix is empty, so that means that suffix is 1 4. Okay. Is that the? Why is suffix 14? Where did I get 14 from? That's not in any of the input. Oh no, it's because it's 14. This is 15 minus 1. I see. Yeah. Okay. So then 14. Okay, and then prefix is empty. Suffix is 14. P is 0, which is true. But maybe I did it wrong. No, this is fine-ish, maybe? This is what I get for trying to combine these two things, I think. Let me... Because I thought maybe I could have made it easier, but clearly it did not, right? So if... Right then, int of xs, let's just do it this way. If, yeah. If the number is greater than or equal to, what you call it? Int of s, then we just have total increment by 1. Okay, now we have greater than, right? Else. Okay, right. You have this prefix suffix thing, right? So here this is wrong too, right? This should be 3 because it should return 15. 10, 110, and 210. Of course, the 10 got double cancelled, but yeah. So 2 is not the right answer. Why is that? Okay, prefix is 2, suffix is 15, P is 1. Is that right? That doesn't seem right. Oh no, it's the number 2. So we don't include 0, so I don't know that we have to remove 0. Because we just pause it. In theory, to include 0, we need a +1. So actually, that I think maybe I kind of messed it up somewhere. Let's take a look. Okay, that's good. That recorded now instead, right? So 6 actually represents 6 numbers from 1, 2, 3, 4, 5, 6, right? So I messed up some counting along the way. But wait a second. Why is the answer? Oh, because the limit is 4. Oh. For some reason I thought that this has to be okay. I mean, that's fine. I see. I thought that finish, the number start and finish has to only include numbers and whatever as well. But clearly that's not true. So that's fine. Okay, that means I have to change some of these things, including, well, this interpretation, because that's no longer true. Because I thought that, why would I think that? I don't know. But yeah, then, because that's just not right. So what would make it right is that, okay, so what does 60 mean? 60 just means So 6 on that digit. I think you just max it, right? That's what I mean. In here, then now you omit it of this or limit. I'm trying to think whether it is limit or limit plus 1. If it's a 4, then it goes up to 4. I think that's right. Yeah, maybe that's right. Let's see. Okay, maybe not. Okay, why is this wrong? For 6,000, you have 1, 2, 3, 4, right? And empty. Okay. So, okay. Oh, because with this, well, there's so many. Because with this, I'm doing this thing of borrowing 1, right? But because of this min limit, we don't have to actually borrow 1, right? Because here, this actually borrows, like it just reduces it to, even if you want to say it's reduced, like it's a 60 prefix, say, so then now it reduces to 59 prefix, but as a result, there's still 4, so this problem is really annoying. I don't know if I'm just doing it in a really annoying way. I mean, maybe, I don't know, but yeah. Because in this case, then you don't subtract 1, is what I mean. I guess it's just whether the first digit is the only digit that matters. Is that true? Because that just determines how much freedom you have, right? After you borrow 1, actually don't change any. Do you change anything else? My head is not really in the game for this, friends. Sorry, but all right. Let's see if I could grind out this finish. But how do I want to write this? It's so awkward because you have 60, which I capped it to 4. Is it even 4? Well, yeah, because 40 in power, in base 5, right? But that's not quite right, because when you're borrowing here, it just borrows it from, it's still only from, in this case, for example, it only borrows from the thing. I mean, in this case, it's easy to figure out, right? But I'm trying to figure out, like, okay, I guess I can write it out, because this case, it makes, like, you know, you cap the whatever is fine, but what you actually want, but you always just subtract 1 before the cap, which is 1. But yeah, we could fix that, right? But now for 1, 2, 4. Okay, let's say we have another digit. What does that mean? How many numbers are we able to have? So we borrow 1, it turns to 59, say. Either turns to 59, and then for 59, it would still be, yeah. No, because then you can't do the sum, because you don't want 59, you still want 40, right? Or yeah, in this case it's actually 4, 4, which is actually way awkward, huh? Isn't it? And additionally, there are some like crazy things, right? Like let's say you have 150, 1, 2, 4. In this case, it's not 15 degree of freedom. It is up to only 1 and 4 if the limit is up to 4, right? But what if you have also another digit, right? So now we have 5. It's not. It's the end is still up to 4, but if you have 2, 2, right? I guess that's fine. Maybe that's fine. Okay, but then now if this is smaller, then doesn't affect this, right? Because now this goes from 255 to 254. Okay, maybe I could just do the prefix thing. Okay, so here, I don't know. We'll see if that works. But if this is the case, then we want to just, and this is just me being lazy, but is you go to string of int of prefix -1, right? That should maybe take care of it. But okay, wasn't sure that I don't even know if this is right. It's just that it's right for the examples, right? So let's give it a quick submit. Hopefully I get to sleep. I have not slept in a week, and I am not sleeping right now. Tell you that. I know my code. I just looked at it. Okay, so you have this, and the string is 20. I mean, this is just off by a lot, right? So that is dreadful. I don't have the head space for this, honestly. But the one day I could have used a easy problem, I do not have a easy problem. Okay, but yeah. What am I looking at? Okay, so we have prefix suffix for the longer thing. And the total is 14, which is way too big, right? Why does it think is 14? Well, you have 1159, right? It's bigger than that, so you have 11 degrees of freedom, right? Okay, fine. Did I do this wrong? I think I did this wrong, in the sense that I counted all the I think I double counted in this. Maybe I don't need this anymore. Maybe I was just confused. I thought I could break it down to that case rather, but maybe I don't need it anymore. Oh wait, okay. I guess maybe I did need it. Maybe? No, that doesn't make sense. I don't think I need this. I think I was just wrong. Why do I need this? I mean, it's fine either way, but I just have to be consistent. Because the way that I take the prefix here, I do not care about it. Or I do care about how it was previously done like this with the number of digits. Maybe that's fine. And then now this just means that we care about only the first digit. Okay, so we could maybe just do a for loop on the first digit instead. Yeah, like almost like if you had a prefix something, right? So okay, let's just break it down, right? So if this is the case, then when does that matter again? Remember that we have all 4 digits. Well, we only care about, okay, so we do it 1 digit at a time, right? I think that's the thing. And maybe we could have cached the other thing, but yeah, basically the idea being that maybe this isn't the right way to do it, but yeah, so for P and prefix, maybe this is a little bit, I don't know if this is quite right. Okay, so you have the first digit, and then now the first digit means that now you have how many degrees of freedom do you have, right? Yeah. So that means that you want something like pow limit +1, and maybe I do need an index thing here. Okay, so the first one means that the length of prefix minus index. So that means that if prefix is 5 digits, the index is 0, then that means that we used up one of them. Okay, so this is that, right? And then this will be min of limit plus 1. Because basically, okay, so the number is, if p is 4, meaning your first digit is 4, then you want to basically do the math for 0, 1, 2, 3, and then the 4 you keep to kind of keep going, right, to limit. So either you have the limit plus 1, except for the first digit. So maybe it's like a digit something that I probably could have done with digit sum, but yeah. Or p times this, right? So this is for all the other digits smaller than p, right? Except for p. Okay. Kind of, because p can only go up to limit plus. Yeah, okay, maybe that's fair. That's fine. And this is p, yeah. Okay, so if you have 4, it's gonna have the 0 to, okay. Except for the first digit, I think. That's because then you cannot have a leading 0. So index is equal to 0. Then it is going to be this p minus 1. So total, we add it. Else, you know, you can just do, right? Same thing. Okay, and then now we have to, okay, so then now we have to prefix a p, right? So what does p mean? So p is just 1, right? But yeah, and basically, and only if p is less than limit, because if p is greater than limit, then you already then these should kind of go all of them, because this should already have it. So p is less than limit or equal to, then what does that mean? Then we have 1. No, that means just we have 1 number fixed, right? So that's good. That's fine. Maybe then I don't need anything, right? Because we have 1 number fixed. Then we go to the next loop. We try all of them other than, yeah, and then just adds up. I think there's like a, the first digit, the second digit. Sorry, friends, it is case analysis. I'm trying to think. For the second digit, what are you doing? Also 1 to, or 0 to x. Okay, fine. But let's say you have 4. Now you take 1 digit, and then now you look at the second one, and then it goes. We already did the math for the other one, so you're only doing it for one case, which is the, you already know the prefix, which doesn't matter anymore. Yeah, so I think this is it. But I'm trying to think about the case, the suffix case. Oh yeah, we don't use the suffix except for the no, even the last character doesn't. We don't care about it at all, right? We only care about it on the very last number. So maybe there is something like maybe we have to add a Oh, I don't know why I had this here, but I have to add on my I think we have to add a +1 if this is the case or something like that, and that should be good enough. Because we never checked the last thing. Hopefully this is it, or close to it, because I'm not confident that it is it. But oh, ow, oops, oops, oops. Okay. It still thinks it's 6 because of this limit 1. Oh, because p minus 1, but limit. Oh. This is also. Yeah. And I know that they cancel out, but I think yeah. Okay, are we close? We are close, so that's good, because 14 was why I was like, oh, we're double counting a lot. Yeah, I know that they double, but it's just more clear why that is. Okay, so 11:59. Oh, so this example, I mean, at least it's closer, but okay, so you have 20. 20, you have hmm. Okay, so we have 11, right? And we return 9, which is not right. No, it's right. It's just that we, for 20, no, maybe it's not right. Yeah, 20, the other one should be returning a 0, so maybe that's, okay. Double check. Because it should run for 19, right? 19 is 0. Okay, just as expected. Double checking. Okay. So then it thinks that it returns 9 numbers. Why does it have 9 numbers? It's limit 5. No, I think it's the other way. That's why. Because it should have already counted it. Maybe not. Man, I am so bad at this. So 6, right? So it goes from if the suffix is less than the. Oh, again, the borrowing thing that we talked about. Because then it tries to borrow from the 6, but it's not quite right in that. Yeah, I think this has to be on the last digit. Maybe that doesn't matter actually, because it's still, you could take it off the loop, it doesn't do another thing. But yeah, okay, so the entire prefix match, because in this case the suffix so then again I'm running into the same issue about borrowing actually. So I think these kind of aggregates, right? But and it goes all the way up to the last P, because then that means that yeah, because prefix is 6, right? So that means that it does this thing, it goes through this thing, probably this thing. So then now this is 5, or this is 5. Limit is what, 5? Yeah, so it's just 5 here. I guess they're both 5 anyway. P minus 1 and this, but 5, right? So it gives you 5. Fine. Oh, sorry, limit of 4, which is 0, 1, 2, 3, 4, which is 5 choices. Okay, fine. No, 0 is fine. There's no leading 0 things. I keep mixing things up. No, is it? No. We already did the leading 0, so this should give you 4, which is right. Actually. Okay, no, this part is right. Obviously, it's not right because, is it this part is wrong? This part shouldn't be wrong. I mean, it's too easy to be wrong, isn't it? I don't know. I wonder how long I did it last time. Okay, 6001. Yeah, so no, this is right. So that means that this part is only returning 3 for whatever reason, and probably because of this. No, 1, 2, 3, 1, 2, 3, 4. So yeah, so this is probably returning 4, but then because of this thing, I'm saying, oh no, you can't do it. But the truth is, you can. Based off the which digit, what number matters the most in whether this gets documented or not. It's okay. So you have to put every possibility. That's fine, except for the number to. So in this case, you have 6, which we cap as choosing the first 4. Which is fine. Right? Why am I so bad at this? Okay, so let's say you have 60, right? Okay, so you prefixed it with the 4 already. Okay, so I guess it's just, if one of the number can be anything, then it already, if one of the numbers can borrow, then it already, everything after that, it should be matter, right? Because it means that every number, okay, so that means that all it means is that if yeah, over is equal to false. So here, if p is greater than limit, then over is equal to true, and then if not over and this, then we have to borrow. Okay, not still not right. I mean, it's fine, and probably usually today it feels a little bit like I'm getting beaten with a stick. Okay, fine. Maybe I should have done digit DP. I just thought that I could have done it a cleverer way. Or I don't know, maybe it's just more intuitive. But okay, so 215 returns 2. That's already wrong. So yeah, so why does 215 return 2? Because it looks at the prefix of 2 and tries to do just 1 and 2, right? Is this part right? Just double checking. Always double check your work. Let's go testing, I suppose. But okay. Oh, I actually printed already. Oh no. But okay, so that means that I do, this part is still right. It's too easy to be wrong. So that means that, oops, this part is wrong. And you have 2. What is the input? 15, 15. So this is, it's not doing this, right? Because suffix is 15 and s is 10, so this is not happening. Maybe something funky is happening here. So 2 index is equal to 0. So then you have 2 degree of. So you just have. It could be 1 and 2. Right? What? Oops. Okay, so for 215, everything. Yeah, or like what I was looking for is that this didn't do anything. But, So this is 2. Why? Limit is big enough. P is the number 2. Oh, maybe this is wrong. Yeah, I guess so. I just needed this limit, I suppose, to have not a 0. P. No. So this is right in the sense that, because we want it to be continued, but then we have to double count the prefix unless this is the case. I'm so off. I think there's so for 6 where the limit is 4, you have 1, 2, 3, 4, right? Yeah, and here it's just too big, so it's fine. But here this should be just 4, right? Why is it giving me 6? Limit is 4 and index is equal to 0. Yeah. Oh, because I do a +1 because okay, so if not over, I think I need something like that. Okay, still wrong, but hopefully a little bit better. They're not over being that if. I don't know if this is actually right, but it means that if you fit the prefix exactly, right? Oh, I see. Well, I mean, this is still really wrong. Maybe this isn't quite right. But if something is over, then that means that everything after that is you don't need the prefix to be exact anymore, right? Because everything after that is good. So I think that's where I messed up. Okay, so with P is equal to limit, then we don't need to do this anymore. We have to do it for the current number, but that's it, right? So okay, because now you're the rest of your prefix is no longer constraints because you can just go over, right? So then you can do the thing where if P is greater than limit, then total we add by, I don't know, something like this. Right, yeah, and then we can break. So, yeah, I wasn't surprised that this is it wrong, but I just kind of put some random stuff together. But okay, so this is power of the limit is 4. Okay, so this gives us, oh, I guess now we no longer need a -1 because it includes the current digit. Yay. Right. Why is this giving me 6 again? Prefix and then 4. I have a +1. No. Oh, because for the first digit, I have to treat it differently. Because it still cannot be 0. Am I confident about this? No. Oh, I did it the other way. But I mean, that is bad, but that's not why I don't have confidence. But oh my god, I just wanted today to end. Okay, 14 being 1 is true. 215 and 2 is not true, right? So you have 215. First number is 2. So okay, why is it not just 2 numbers? Should just go to here and then that's it, right? Like, if it's not, and this doesn't trigger, so why are you tormenting me? Yeah, so okay, total is 2. It should be 3, right? Yep. So that means that this only adds once. Why? 215. So the number is 2. Index is 0. This is 2. Oh, did I not fix this? I thought I... Huh. Okay. Well, let's see. 1159. Am I double counting again or something? Why is this so high? Okay. So we have 11. Right? No max. So it has to do the prefix. That's fine. But let's move that because it's not useful anymore, maybe. Or it's not going over this. But yeah, 11, right? It's the prefix, so it does 1. It cannot do so this should be because this is returning 1 is why, but it cannot be because of the leading 0. So maybe it does need to be there. Yeah, maybe it does for the leading 0 reasons. But then what am I doing wrong here then? You have 2, right? 2 is lower than the limit. It's still, oh wait, can this be leading 0? Is that why? No, I think this isn't right, but why is this? Oh, because it thinks that P is 1. And then it's just 1 times. What am I doing math wrong here? If it's 1, then it cannot be. Yeah, that's true that this is this. Yeah, wait, no, the other one is wrong. This one is wrong. Because it should assume that 2. And then now we have, okay, yes. So then now we have the prefix done. Because we don't, oh, it's the first digit thing. I think it's because, yeah. The first digit I'm not handling correctly, I think. Because it cannot have, because you don't. So this is right in that you don't want a leading 0. Right? But as a reason, no, wait. Yeah, but then it assumes that we use this number as the exact, so we don't count this number. That's what this stuff is meant to say. But then now, I think I just needed one more loop or something. But yeah, where in this case then I don't know why I didn't just do prefix dp, but now when it's all done, then yeah, the entire prefix, and if it's possible if int of suffix is greater than equal to int of s, then we increment by 1, right? Okay, and here we overcount. Why? 19 is no good. That's true, and that's fine. Otherwise we have, okay, the first thing we have 9. Why? No, because do we count the prefix 0 correctly? It may be that we don't, because I feel like that's the part that I'm a little bit bad at. Okay, so okay, right. I think I just need to take this out. I don't think I need. I don't think I need this. I think it's mixing me confusing. Oops. I think that was giving me issues, because then now we can have leading zeros. I don't have to do like crazy things. Yeah, maybe I should have done away with to begin with, but I was trying to, I don't know, I just got stuck in that concept of case analysis. And this may still be wrong, honestly, because I don't know, I'm not confident at all, but and there you go. But I am like an hour in and I'm tired, so I'm gonna, just abuse the test cases, but if it lets me. But okay, so 9 digits, 72. Yeah, there's some, so I put 8 as in 0. Yeah, 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6, 7, 8. There's 9, right? Why did I put 8? Because I don't. I put 8 because. No, there's this thing. I think it is. If one of them is okay, but I feel like if you have both, something is wrong. That I always thought that was a smell, honestly, and as soon as I realized what I'm doing, I was like, I don't need it. We don't need to do over anymore, because that's, we just checked for the. All right, give it a quick submit. The submit is quick, but the problem is hard. I think honestly, looking back, I should have just done maybe digit DP, but maybe I just didn't have the cases quite right anyway. But yeah, I mean, looking at the code now, it doesn't look so bad. It's just that I think my main mistake was that I was trying to break it down too much of a case, and that lead to like leading zero issue, which I guess I didn't really need it to take care of if I had thought about it in the right way. But yeah, hopefully this makes sense. It's just really, the concept is not that hard. I think I broke it down too stupidly, like many things I've done today. So yeah, let's just call it a day. My apologies if this video has been terrible, but yeah, this is O of n, where n is the number of digits for each number. So yeah, and it's just basically one digit at a time. Just okay, I will go over it quickly. So yeah, one digit at a time is that, okay, so let's say your suffix is equal to, I don't know, 125 or whatever as a suffix, and then now you have some prefix of this, right? So then now what I'm doing is that I go with, okay, well, let's just do the digits one at a time, right? So then now we would start with 0. Well, if it's 0, and you could pretend that we removed the leading 0, that means that everything in between here is working, right? And also 1, that means that everything in between is working, and that in between is just it's this power formula, but that just determines number of digits you have left and the number of limit that you're given, right? So that's basically that. But then when you come to 2, you can't do that anymore, right? You can't just do 2 any number, so you have to do 2 2 0 and then any number, right? And then 2 1 any number, right? And of course these are all the same, so you can go the second digit. I'm pointing at it like you can see me point, but like dot it, right? And then now 2 5 like 2 4 it's fine, but 2 5 you can't do that anymore, right? So you have to go one more digit. It's 1 1. And then now we do okay, well 1 2 6, right? Actually, I lied. This should have been 0, and you kind of have freedom for the other ones, but that's fine. And then now you have this way as well. And then at the way, but remember that the way that we wrote it, or by we I mean this guy is really bad at writing it, is that it assumes it skips the exact prefix, and this is why I have this here. Is that now that the prefix is entirely done, that means that we're testing this final number one more time for the increment total, and that's basically the idea. And I said at the beginning, if you had the right implementation infrastructure, you could have been good. But I kind of was trying to break it down a little bit too much, and ironically, that created more special cases, which I don't know. Maybe today I just didn't have the brains to kind of pick that apart. But yeah, hopefully that makes sense. Hopefully that is okay, and hopefully I will get to go to sleep. And yeah, that's all I have for this one. Thanks for watching. Stay good, stay healthy, to your mental health. I'll see you later and take care. Bye bye.